Hi, I'm Eric Wostrow. I'm from the University of Michigan, not Waterloo, unfortunately, but well. In any case, I'm going to be talking about Telex, which doesn't have much of a relation to our generous sponsor, except I guess we have a Levenstein distance of 1. So without further ado, oops. So the problem that we're talking about today is one of government internet censorship. And this is really a global problem. It's not just concentrated in a handful of countries, like you've probably heard of China and maybe even Iran, but it's really spread across the world, and all sorts of different countries censor for lots of different reasons. So some do it for political reasons. They don't like to have opposition in their politics. Some do a lot of pornography censorship. Some even just gay and lesbian dating sites are banned. And there's also a lot of religious censorship too. So this is a really widespread problem, and we're trying to attack this we're trying to attack the problem of government internet censorship. So pretty widespread problem. And so how do these government censors work? Well, they basically all use a blacklist approach. There are a few that use other techniques, but the main technique that we've seen is a lot of blacklists, where they go out and they find offensive content for whatever offensive means for them, and that's the pornography or political stuff. And from a technical level, they basically use these 3 techniques, which is IP blocking, DNS spoofing, and forged reset packets. And so the IP blocking is fairly straightforward. They block websites' IPs. They'll do DNS injection. They'll poison DNS queries with bad IP addresses for things like Facebook.com or YouTube. And they also do some deep packet inspection. And so if you send a search query or something like that over the clear for a banned search term, they'll send a reset packet to both sides of the connection and close it. And you've probably heard of some of the countermeasures that people have tried for many years to get around this type of censorship. So you've heard of VPNs or Tor, Freenet, and Ultrasurf. But the problems with those types of proxies is that you have to communicate the proxy's location to the citizens without communicating it to the censors. Because if the censors find out about it and they don't want their citizens accessing these proxies, they can just block them using the same techniques that they're using to block the websites. So it's a very cat and mouse game between the censors and the users and the people running the proxies, and so it's a lot of effort on everyone's part. And so just to illustrate this a little further, I want to quickly go through Tor. And Tor is a proxy that was designed for anonymity. So it's not an anti-censorship proxy, although it is often used for anti-censorship. It was primarily designed as an anonymity providing proxy. And how it works is, say that Alice wants to talk to Bob without Bob knowing that Alice is talking to Bob. Well, Alice will contact the Tor directory servers and say, hey, I'd like a list of all of the Tor nodes in the Tor network, if you will. And once Alice gets all of those nodes, she'll pick 3 nodes that she likes and use those as a proxy. And so she'll establish a connection to the first one, use that connection to the first one as a proxy to talk to a second Tor node, and again use that tunneled connection to the second node to talk to a third node, and finally use that tunneled third hop proxy to talk to Bob. And you can see how this is an anonymous protocol because no single Tor node can tell both that Alice and Bob are communicating. Only the first Tor node knows that Alice is even talking to Tor but doesn't know where she's going. The last Tor node only knows that someone in the Tor node is talking to Bob, and the middle Tor node knows nothing. But it's really easy for a censor to block this, right? Because all of these Tor nodes are public. So someone like China just goes to the Tor directory server and says, give me all of the Tor directory servers. I'd like to connect to Tor. Yeah, right. And then adds all of those IPs to their block list. And all of those are now blocked in China. So Tor has an answer for this. They've come up with something called Tor bridges, which you may have heard of. And the idea here is that they're going to create some nodes that are not public. These are just hidden bridges. These are Tor nodes just like any other node. You can connect to them, and they act as Tor entry nodes, but they're not publicized in the public Tor directory list. But again, we have to get these Tor nodes, or these Tor bridges IP addresses to citizens in the censored countries. And so they have a number of mechanisms for doing this. This is just one of them. You can go to bridges.torproject.org and they'll give you 3. And if you ask again, they'll probably give you the same 3 until you change IP addresses. But there's a number of attacks that allow people to enumerate these Tor bridges. And these are actually pretty effective at enumerating the several hundred Tor bridges that are out there. And to the point where China has done this, and they're not alone in doing this. And it's really hard to use Tor in China, despite this add-on to Tor. It's really unreliable, and most of these Tor bridges are blocked. So our approach is fundamentally different. We're looking at this from an anti-censorship from the beginning. We're not trying to do anonymity. We're trying to do anti-censorship from the start. And we sort of arrived at the idea that we should put a proxy in the network. We think that this is a lot harder to block than something that's end-to-end or just IP-based, where you're talking to some IP address that can easily be blocked or something like that. So we're focusing on avoiding detection, and we think that this complements something like Tor. It's not like we're trying to beat out Tor or anything like this. This is just sort of a different direction. And the main thing about our system is that there's no secrets. There's nothing that is secret to only the users of the system and not the censor. Everything is public. The censor can know exactly how our system works, all of the IP addresses involved in our system, and still have a difficult time blocking it or preventing access from users. So let me just go through the threat model that we're looking at, just so we can be clear what we're talking about. We make basically 3 basic assumptions about the censor in question. So this is, again, the government level censor. This is the China or Iran or name your favorite country that's doing censorship, which is probably any of them. So the first assumption we make is that the censor controls their network, right? They control all of the routers in their country, but they don't control routers outside their country. They can buy hosting or VPNs outside their country, but not, they don't own large infrastructure. The second assumption we make is that the censor is, again, doing this blocking based on a blacklist. So they're looking out for, we use the example, blocked.com is the website that the censor says that has some offensive content. We're going to block that. So if you try to access blocked.com from inside the country, it's blocked. On the other hand, not blocked.com doesn't have any offensive content on it, and so you can access that from inside the country. And finally, we make the assumption that the censor will allow HTTPS connections to these non-blocked sites. And there's a lot of reasons why they would do this. There's a lot of websites moving toward HTTPS. There's something over 1.5 million websites on the internet now that are serving valid signed HTTPS certificates. And lots of these are logins for sites, email, a lot of e-commerce, and so it would really hurt the local economy and among other things if they were to just outright block HTTPS. So let me go through the high-level overview of how Telex works in this threat model, and then we'll drill down into some of the details a little later. So again, the client here is on the left. And is trying to get to this blocked.com, but the censor here, this gray wall, is blocking this connection because blocked.com has some offensive content. So instead, the user is really wanting to get here. So the user downloads the Telex client binary, and they could have gotten this from perhaps a trusted friend or maybe an intermittently available proxy. Tor was up for 5 minutes today or something like that, and they used it to download Telex. And they're going to install this on their computer, which is going to intercept their request to block.com and instead generate an HTTPS connection to notblock.com. And this is, of course, allowed by the censor because it's an unblocked website and it's HTTPS, sure, why not? And the connection goes through. Now, inside this HTTPS connection, the Telex client is going to place an invisible tag. And this invisible tag is constructed in a special way that the censor cannot see it. And we'll talk about more of the details of this invisible tag later. But along the path, along the connection path between the user and notblock.com, there's a number of routers, and along one of the routers outside of the sensor's country, we place a Telex station. And this is our proxy that we're placing at some ISP's router. And this position in the network allows us to see the packets going between the client and notblock.com, and most importantly, see the invisible tag that is in this connection. And the way we were able to do that is because we have a private key in the Telex station that the sensor does not have. And this private key is associated with this tag, and people with the public portion of this can generate tags but not check to see if tags exist. But only the private key can see these tags exist. And so once this happens, the Telex client is going to place inside this HTTPS connection the request for blocked.com. And because of the private key in the Telex station, we're able to decrypt this request, and only we are able to decrypt this request, and proxy it for the user. And so we send this request to block.com to the proxy server and get the response. And when we send data back to the user, we actually spoof it from notblock.com and re-encrypt it and all of that. So to the sensor, this looks exactly like an innocuous HTTPS connection to notblock.com. So there's a lot of things going on here. There's deep packet inspection, there's man in the middle, but we're using this for anti-censorship instead of censorship, which is what those techniques have been used for previously. So you might say at this point, okay, well, why would an ISP in their right mind deploy something like this, right? This is kind of crazy. But I don't think there's any single reason why I don't have like a single reason that I can convince you all that you should all deploy Telex at your ISPs today. But I think there's some good arguments for some ISPs that could be convincing for some of them. So one is to advance the state of art of research. And what we're looking at is things like deep packet inspection and man-in-the-middle attacks, but for good, and steganography. And I think that that's actually a pretty motivating reason for a lot of research-oriented ISPs to be looking at something like this. There's also government incentives. Our government, as well as many others, has previously sent money toward anti-censorship proxies and projects like this. So there's some potential funding there. And finally, the ISPs are really in a unique position to help in this instance. And I think that that's a sort of powerful motivator, at least for me in terms of working on this project, is that the internet was really designed as an open technology, and this censorship is very counter to that. And this type of technology is, as Telex is a technology that sort of counters that counter. So I want to talk a little bit more about the finer grained details of what exactly Telex needs and what exactly Telex would require from an ISP deployment. And to do that, I have to talk a little bit about the lower layers of how we work. And so we're doing this all over TLS, so you have to understand a little bit about TLS, and I'll walk a little bit through how TLS works briefly. But essentially, when you create a TLS connection, this is over TCP, you send a number of messages back and forth between the client and server, and this establishes a secure channel between the client and server. So the first message in the TLS handshake is normally the client hello message. And inside the client hello message, there's this nonce that is designed to protect against replay attacks. Normally, this nonce is chosen randomly by the client, but in Telex, we replace this nonce with our invisible tag. So it's a really good location for our invisible tag. And again, this invisible tag can only be seen by the Telex station with the Telex station's private key. It can't be seen by the sensor, and it can't even be seen by the notblock.com. So using the private key, the Telex station observes this and says, oh, I will need to do some proxying for this connection. Another message that's sent in the TLS exchange is the key exchange, and this is what establishes the shared secret between the client and the server that they use for encrypting and authenticating all of their data. Normally, the client chooses a random value for its key exchange and does some math and sends it to the server. But in our case, we're replacing that random value with a shared secret that was communicated to the Telex station inside the invisible tag. And so this allows the Telex station to extract that shared secret, figure out what the shared secret that is now being used between the client and the server is, and allow us to decrypt that TLS connection between client and server. Now remember, this doesn't work on just normal TLS connections. The client has to cooperate and leak this information to the Telex station in this fashion. But it allows us to man-in-the-middle connections that want to be man-in-the-middled in this fashion. And so finally, the Telex station makes sure that it has gotten all this math right, and it looks at the finished message, which is an encrypted and authenticated digest of the previous messages in the handshake. And once it has verified that, yes, it indeed does have the shared secret between the server and the client, it turns into an active man-in-the-middle. And now we get to actually receive all of the packets from the client, read what they are, and we can spoof as notblocked.com and re-encrypt things on the way back. And so at this point, the client sends the GET request for blocked.com encrypted with the shared secret of the TLS connection. So how does this invisible tagging work, right? This is sort of the secret sauce of this whole thing. Is how do we keep this secret tag secret from the sensor, but anyone is able to generate it? And that's really the thing that we want from this, is we want something that anyone can generate, anyone including the sensor. The sensor can generate tags, clients can generate these tags, but only the station can detect these tags and decrypt these tags. And we have a number of requirements for this tag. It has to be short. It has to be 28 bytes so it can fit inside the client hello's random nonce. It has to be indistinguishable from random unless you have the private key, because it's replacing a random value, and so the sensor can look at the connection and see if we replaced anything else that was supposed to be all zeros. They would say, well, that's not all zeros. And it has to convey a short shared secret, which is what we use to leak the shared secret between the client and the server and allow us to decrypt and man-in-the-middle the connection. And finally, for performance reasons, we want it to be fast to verify and recognize and have low false positives and all those nice things. And the solution that we came up with was using Diffie-Hellman over elliptic curves. And I won't get into the math details of how all this works. If you're interested in that, please see us after, perhaps during lunch, or read our research paper. There's plenty of details there. But this is an application of public key steganography. So we have a working prototype at this point, and we've been running this out of our lab at the University of Michigan. And I just want to go quickly through what we've done and what we plan to do in the coming months and this year in terms of actually getting this deployed and scaled up. So I'll start with the Telex station. It has basically three components. It has a flow diversion, a tag recognition, and a proxy service component. The flow diversion component is basically a bump in the wire. It's the inline switch in the ISP, if you will. And it gets to see all the traffic between the client and the not blocked websites. And in order to make it so that when Telex was under load or under denial of service or something like that, or was in a failure mode, but we still want to route packets, we still want non-Telex connections to go through just fine and be unimpeded, we made it so that this router is able to be commanded to block flows once the tag recognition sees something that it notices is a Telex connection. So in that mode, the tag recognition falling on the floor or getting rebooted or denial of service is not going to impede regular traffic. Regular traffic is always just going to flow through the router and not have to go through the bottleneck of our deep packet inspection or anything like that. And so the tag recognition is the thing that's sort of below the flow diversion and gets to see all of the packets going through if it can keep up with it, and command the flow diversion to, yes, this is a Telex flow, I'd like to look at this more closely. And so that has to do all the deep packet inspection, the TCP flow reconstruction, the extracting of the TLS nonce, and et cetera, et cetera. And finally, we have sort of the last component is the obvious proxy service component. So this is the actual what we forward this traffic to once we decrypt it, and what we get traffic back from that we have to re-encrypt and spoof as notblocked.com. And we implemented 3 different proxy services. One, a Squid HTTP proxy, 2, a Tor bridge, so you can use Tor on top of Telex, and also an SSH server that only accepts SSH logins over Telex. And from the client side, we have a small source distribution of code that's available for both Windows and Linux that you can run on your computer that basically acts as a local HTTP proxy for your browser and redirects all of the requests through these encrypted connections to notblocked.com. In our test deployment, we have, like I said, a very small ISP that has all of 2 websites behind it. One, notblock.telex.cc, and that is simulating our notblock.com. That's the uncensored content, and it's unoffensive to almost any content provider or country that I can think of. And the second one is a blocked.telex.cc, which simulates a blocked website, and we simulated that by making it only accessible from users of Telex. And 3 of the authors on our paper use Telex for their daily browsing for a few months, and I've been using it since July personally, and been able to have minimal complaints. The complaints that I did have usually resulted in bug fixes, so that's always good. And we were able to stream high-definition YouTube videos from a Planet Lab node in Beijing, China. And Beijing in China actually blocks YouTube, so this was something that was kind of nice to be able to prove that we were high bandwidth enough to handle high-definition YouTube. And in China's case, actually, once we released this, we had a lot of support from a lot of Chinese users using our service and our proxy. But ultimately, the Chinese government decided to block notblock.telex.cc, which was sort of entertaining. First, they started with DNS blocking. And then we said, oh, well, we can get around this. You guys can now use notreallyblocked.telex.cc. And within a day, they had DNS blocked that as well, and IP blocked it as well. They were quickly escalating this to, we're not going to keep playing this game with you guys, go away. But if you look at notblock.telex.cc, you really have to wonder, why did the Chinese government censor this, right? This is a really innocuous website. It's just kittens served over HTTPS. So I sent a complaint to abuse at CNNIC, asking why my popular kittens website was blocked in their country, and why I had not had any more users from their country in a number of days, and I'm still waiting to hear back from them. So this is the users around the world from the first 3 weeks of our deployment. Obviously, it was pretty worldwide, which was great for our evaluation and testing of our system. And it's sort of shifted more recently to a lot of China and India is a lot of the users. But we've had over 75,000 users since launch, and that's been pretty exciting for us to run a small proxy for them. So next steps. This is what we're looking for from this room, I guess, and this community in general, is that we're looking for partners to move to the next level, which is to actually deploy this at a real ISP, so that we don't have a single website that's hosting kittens that gets blocked by the Chinese government. We want to have thousands of websites behind it, which will make them really think, well, should we really block all these websites? And it might make the collateral damage for blocking that much more difficult for them to do. For a direct, what we actually need from an ISP to deploy at an ISP is we're looking for basically a TCP tap off of port 443 and an inline OpenFlow switch. And we're currently developing an OpenFlow extension that will allow us to do this sort of man-in-the-middling and tag recognition of fast traffic. So if you're interested at all in talking to us during lunch or during the break, please do so. We would be very happy to talk to you. So just to wrap up, this has been our new approach to resisting internet censorship, and we've been using our new technique, which we call end-to-middle proxying, as opposed to end-to-end proxying, where you're using IPs as proxies. And we're focusing on hiding the service. We're not an anonymity thing like Tor, but we're focusing on making it so that the censor can't tell that users are using this proxy and can't, more importantly, block this proxy. And like I said, we have a proof of concept that's operating today. I encourage you all to go check it out. Our website is telex.cc. And thank you very much. I'd be happy to answer any questions at this time.
Hi, Jake Kuhn, IP Infusion. So you've told us about your efforts, or about this, the benefits, your perceived benefits for deploying this. I'm assuming you've had conversations with other ISPs rather than just the one in Michigan. And could you share with us some of the reaction from them? And could you tell us why it would be not beneficial to deploy this?
So yeah, that's a good question. So one thing is that obviously we're putting an OpenFlow switch in someone's production network, and so people are obviously very nervous about that sort of thing. They're hesitant if this experimental type thing would actually result in loss of customers, essentially traffic or something like that that might screw up their internal network. And we have some ways that we can work with ISPs that might help mitigate some of that. You could, only source us the traffic from some of these censored countries that we care about that you probably don't have too many customers or destinations in. But I think right now we haven't talked to too many ISPs. We've only talked to a small handful, and most of the ones we've talked to have been sort of not against it, but they've been not, oh yeah, let's deploy this tomorrow or something like that. They're sort of just hemming and hawing and sort of seeing what will happen. So I don't know if there's any huge disadvantage. I mean, maybe some other people can come up with some in this room for deploying this sort of thing. Did you have any in mind that?
Well, I'm wondering if they gave any reason for the reluctance in particular, whether it be political, economic, financial.
One was one of the most specific ones was that they were worried that their customers would be under a greater risk of being attacked by these countries. And I don't necessarily agree with that statement, but that was one of the reasons that was given from one of the ISPs we talked to.
Eric Osting with Network Utility Force. I don't generally consider myself a tinfoil hat person, mm-hmm. But your suggestion that there may be government incentives associated with deploying this work sent a number of chills down my spine. Perhaps you could tell us a bit about any government involvement that has been associated with the project so far.
Sure.
And what you might do to counteract possible tampering.
Yes. So to answer your first question, we had no government funding from our project whatsoever from any government or private organization in initially developing this. So this technology is just developed at the University of Michigan and University of Waterloo, and there's no government involvement from that. As far as government tampering is concerned, yes, this is a proxy. The government could potentially snoop on this like any other proxy, but if you're concerned about that, we encourage people to run Tor on top of Telex if they're concerned about anonymity. Like I said, this is not an anonymity providing proxy. This is for anti-censorship.
We're running a little short on time. We're going to cut it off to the people at microphones. Next question from stage right over here.
Hi, Arpad Kun, Ustream. How do you come around the problem if, for example, let's stay with your Beijing example. So, Beijing, your proxy, mm-hmm. Somehow this proxy or the information or actually your private key on this proxy is exposed to China, and they do a man in the middle into the man in the middle.
Yeah. So what if our private key gets compromised?
Yes.
So we have a number of mitigation techniques for that that's in the paper. One is to use short-lived private keys, and we can have lots of public keys that, one used every 5 minutes or something like that, and that certainly makes it harder to compromise any single one. You can talk to me afterward and read the paper for more details on that.
Okay, thanks.
Next question from the gentleman in the hat.
Thanks, Greg. Louis, Equinix. Not that you're a lawyer, but I'm wondering if you guys have discussed or explored what risks there would be to ISPs or U.S. citizens getting hit by DCMA warrants from the use, not authorized use by U.S. government of this service?
So I'm not sure, obviously I'm not a lawyer, but I think it would be similar to other proxies or VPNs that are proxying traffic for people outside the country. I don't know exactly what they fall under, but I assume we would be similar to that.
A couple of questions. One of them is somewhat technical. Jay Hennigan with Impulse. One of the somewhat technical is 28-byte nonce. If that is indeed going to be something that triggers the router to route this to Telex, could not statistical analysis show that that is not random, and these nonces that are known would then be, any message containing that nonce would be censored?
Yeah. So
the other question is, how secure, how can we ensure that the Telex client itself is secure? If nonblocked.com happens to be my bank, and I am running Telex to avoid censorship, I don't particularly want a man in the middle in that transaction.
Okay, so to answer the first question, the invisible tags that are generated with elliptic curve and hash outputs are indistinguishable from random. And when I say that, that's computationally indistinguishable from random. If someone were able to distinguish that from random, they can do some other nasty things like reverse hashes or decrypt elliptic curve encryption or something like that. And there are more details in our paper about that too. To answer the second question, we are only man-in-the-middling the connection to your bank, but you're not actually not to your bank, but to the not blocked site, and you're not actually using that connection to talk to not blocked. If you wanted to talk to your bank, you'd talk to your bank through Telex, and that connection would be end-to-end encrypted, and Telex wouldn't be able to snoop on that unless you additionally tagged that as well. So.
Thanks a lot, Eric.